We are going to work on simplifying radicals. So, pardon me, if it looks like this, the number in the little notch is called the index. And the number under the radical is called the radicand. I use the phrase index a lot. I very rarely use radicand. I usually just say number under the radical. If you have an expression like this, and there is no number in that little notch, how would you read this? How do you say that? What? How else could you say that? Anybody? Radical 5. Go ahead. The square root of 5. This is the square root of 5. Okay, so she said the word square. When you say the word square, what index are you implying that is here then? 2. If there is nothing here, that means an index of 2 is implied. There we go. If it was any other number, so sometimes in math we don't put a 2 there because it's the most common. If it was anything else, we would have to write it there. So if we want the index to be 3, 4, 5, anything else, you have to put the number in the notch to tell everyone what your index is. This would read the cube root of 5. All right, so we might have an index, and the number under the radical might also have an exponent. We can go back and forth between radicals and exponents by rewriting that as a to the exponent of m over n. So what is super important, what is your takeaway here, is that the index is the denominator. So if you needed to rewrite this, which we will eventually, the index is the denominator. So we are going to simplify some expressions, and so it is helpful if you know your perfect squares. All right, so if you had 2 to the second power, what do you get? Go ahead, shout it out. You got this. 2 squared. 4. 3 squared. 4 squared. 5 squared. I heard it dropping off. Hopefully it's 25. 6 squared. 7 squared. They're saying 49. 8 squared. What's 8 times 8? 64. 9 squared. Thank you. 10 squared. 10 times 10? 100. Good. I'm going through 12 today. 11 squared? Good. 121. And 12 squared. Perfect. All right, so we have our perfect squares. There are lots of ways to simplify radicals. This is the method that I'm going to use. So it is helpful to have this information handy. If you do not know what your perfect squares are, you can just always make this list. Now we're going to figure out what the perfect cubes are. So now instead of raising the number to the exponent of 2, now I'm going to raise all these exponents to 3. You can take 2 times 2 times 2 in your brain, or you can use the exponent key on your calculator. What is 2 to the 3rd power? It is 8. Good. Most people in this room have this calculator right here. So if you wanted to take 2 to the 3rd, you put in the base, you hit your upside down V, that's an exponent, and then you would put a 3 there, and that is how I got 8. The next one I'm about to do is 3 to the 3rd, or 3 cubed. So you're going to go 3, hit your caret button, and put a 3 again. 3 to the 3rd equals 27. We don't do nearly as many of these. I'm going to go through 5. What's 4 cubed? Good, 64. And 5 cubed. Good, 125. There might be a couple on Delta Math that do 4th roots. I might do one on the notes, I can't remember. So what is 2 to the 4th power? Very good, 16. 3 to the 4th. And 4 to the 4th. It's the only ones that I want here. 3 to the 4th equals? 81. And 4 to the 4th. Good. 256. One moment. All right, so I just really wanted to make sure that you had this information at the front. Now what we're doing is we are going to show you how to go back and forth using radicals. Take it using exponents and go back and forth. So we have n a to the m equals a to the m over n. So we're using this idea from initially in the page. All right, so I have this radical here, and I would like to write it using a fractional exponent. So the first thing you have to know is, what is your index? What is the invisible number in the notch? 2, 2, okay. This one has an exponent right here, but this one does not. If a number does not have an exponent, what is implied to be there? 1, perfect. So this we would write as 15 to the exponent of 1/2. So the square root of 15 and 15 to the 1/2 are the exact same thing. They're just different representations. So now I have an exponent, and I would like to write that as a radical. What does 7 to the 1/2 look like as a radical? Radical 7, good. That is the square root of 7. So the 2 goes in the notch, but 2 is implied. It doesn't need to be there. This says the cube root of 17. How would I write that using 17 and some fractional exponent? Good, 17 to the 1/3. So what you have to know and recall is the index is the denominator. When I did that, the index is always the denominator. 18 to the 1/3, what's that going to look like as a radical then? Hopefully in your head you were thinking the cube root of 18. So the denominator becomes your index. It's a 3, so you have to write it. It cannot be implied. And I'm going to hit the pause button, and why don't you guys try 5, 6, 7, and 8. All right, this one, that should have been the cube root of 16 squared. Fun fact, so the exponent on the 16. There are choices. So that 2 can either go inside the radical or it can go outside the radical. These are the exact same answers. This would be x to the 2/3. This would be the 7th root of m to the 5th. All right, so we have this one. We have a 12, we have an x, and we have a y. So each of these needs its own individual exponent. So this would be the same thing as 12 to the 1/3, x to the 2/3, y to the 1/3. So you need to do it like this because we might need to break them up each individually. All right, so on number 9, we need to simplify. My steps are going to be, number 1, write the number using perfect squares, if it's not already a perfect square. Number 2, you're focusing in on the variables. You divide the exponent by the index. There's no index here. What is your implied index? 2. Okay. Would you agree with me that 49 is a perfect square?
Yeah.
Okay, what's the square root of 49?
7.
Okay. Once you take the square root of a number, it comes out from under the radical, and there should be no radical around the 7 because you performed that math operation. Now, we're going to focus in on the A. So the rule is you take your exponent, which is the 8, and you divide it by the index, which is an implied 2. What is 8 divided by 2? 4. All right, so that says that 4 A's get to come out from under the radical. So that is 7a to the 4th. All right, so if you're having trouble with your variables in this rule, I mean, it's not so terrible when they divide evenly, but what if they don't? If you are going to have the square root of a squared, we've done this before, yeah? What is the square root of a squared? It is a, because that exponent and that index, they canceled each other out. Go ahead, Travis.
Could the 7 and number 9, could that be positive negative? Does the square root of 49 be either of them?
It is, if it's an expression and the radical is already around it, it is implied that we are only using the positive version of the answer. If you are solving an equation and you are taking the square root of both sides, then that is when we give it the plus minus. But yeah. All right, so what if we have a to the 8th, do you know that that's the same thing as 8a's under the radical? A to the 8th is the same thing as 1, 2, 3, 4, 5, 6, 7, 8. Do you know this? It is. A to the 8th, because exponents mean repeated multiplication. So a to the 8th means that there should be 8a's under the radical sign. That's what that means. All right. So this index was a 2, and that exponent is a 2. And so that basically said, so you're telling me that for every 2 a's under the radical, one of them gets to come out. That's really what we're saying here. All right, so when I was a student teacher, my geometry teacher taught me this thing. And so here's how the story goes. So you have a radical sign, right? Kind of looks like a jail cell. So you have this jail cell. So you want to escape jail, right? So in order to escape jail, you have to find a buddy that looks like you. So like A's look alike, B's look alike, 2's look alike, that kind of look alike. So jail's a violent place, right? So when you escape jail, one gets out and ka-cha, the other one dies trying. So here you have A, he found a buddy. That A, he found a buddy. That A, he found a buddy. And that A, he found a buddy. So you had 8 prisoners in jail, and only 4 of them escaped and came out alive. Great stupid story? Yes. Maybe you will remember how to simplify variables. All right, let's go again. The next one is the square root of 48. We have x, we have y's, we have z's. So we have 4 things that we have to deal with. We have a number, and then we have these 3 letters. Okay, so the first question is 48 a perfect square? It is not. So now you want to ask yourself, what is the biggest number that divides evenly into 48 that is a perfect square? So this yellow highlight right here, these are your perfect squares. When we are simplifying radicals, these are the only numbers you're allowed to divide by. These are the only ones. So when you take 48, which one of these is the biggest number that divides evenly? Maybe you know, maybe you don't. Get out your calculator. What are you saying, Katie? 16, okay? So 48 breaks down into the product of 16 times what? 3. And then I have x squared, y to the 4th, z to the 12th. All right? So sometimes to keep myself organized, I circle the ones that are perfect squares that are about ready to come out. So what's the square root of 16? 4. So it gets to come out from under the radical. This 3, is it a perfect square? No, it has no hope. That's a 3, everyone. My bad. One moment. There we go. It has no hope of coming out from under the radical, so it stays right where it is. All right, so when it comes to variables, A, you can write them all out. B, you can divide by the index. So there's no index here. What's implied to be there? 2. So you're going to take every exponent divided by 2, and that tells you how many variables get to come out. So what's 2 divided by 2? 1. 4 divided by 2? And 12 divided by 2. Okay. So on the x's, so all of these are the exponents outside of the radical. So you got to pull out 1x, 2 y's came out, and 6 z's came out. I know that an exponent of 1 is not necessary. If you don't put a 1 right there, that's fine. It's not necessary. If you like it to keep yourself organized, that's great. That is your good, fully simplified answer right there. All right, now we have an index of 2, but our variables start having some odd numbers, so we're going to have to figure that out. When you stick a number right in front of an operation, what is happening between the 3 and the radical term? Is the 3 and the radical, are they being added, subtracted, multiplied, or divided? Multiplied. When I don't have a sign there, there's multiplication. All right, so I have 3 outside. I'm going to deal with everything. I'll deal with that in a minute. Now, I have the number 300. I want to rewrite that as the product of perfect squares. What is the biggest perfect square that goes into 300? 100 does, okay? So that would be the product of 100 times 3. I'm just being creative. I'm rewriting it. Those numbers are still under the radical. Nothing has happened. I have a to the 5th. So for funsies, we're going to write out 5 a's. 1, 2, 3, 4, 5. B to the 4th. C to the 2nd. I have 100 here that I just circled because that seems to be a perfect square. What is the square root of 100? 10. So that means that a 10 gets to come outside of the radical. So I was trying to establish earlier that there is multiplication happening here so that when you pull out any number or letter that, and there's already one out there, multiplication is the thing that we're going to do with them. All right, so for the A's, if you were doing a prison break, all right, so I have a group of A's there. I have a group of A's there. That odd man out, he couldn't find a partner to break out of jail. So you know what's happening to him? He's stuck. He's still in jail. He's not coming out. So I get to pull out, so I have 2 groups here. So that means I get to pull out 2 A's. And then we're going to have this 1 still stuck under. All right, B to the 4th. I'm going to deal with this A in a minute. But for the B's, these are even numbers, and so you should be able to apply this logic. You take your exponent divided by your index. 4 divided by 2 equals 2. That's how many get to come out. And then I have c squared. So what's 2 divided by 2? 1 gets to come out. All right, so I have b squared c. This 3 and this a are not circled. They cannot come out from under the radical. I'm almost done. 3 times 10 is 30. A squared, b squared, c, radical 3a for your good final answer. Let's talk about a to the 5th for another moment. All right, so if I have a 5 divided by 2, don't give me the answer as a decimal, but what would this be as like a whole number and a remainder? So 2 goes into 5 how many times? 2. With how many as a remainder? 1. Remainder 1. So if you have a number and it does not divide evenly by the index, do it like this. Figure out what would be the answer as a mixed number, basically. What is the whole number and what is its remainder? The whole number tells you how many get to come out, and the remainder tells you how many stay in, how many are still stuck under the radical sign. So this matches up with my answer. So if you are a kid who likes to circle it, that's great. If you would like to try to divide, here's how it goes. So that 2 is your exponent on how many get to come out. You have 1 left over, and so that's the guy that's stuck under the radical sign. Now you need to switch your brain a little bit, and the next 3 are all cubes. So now you need to go, all right, so now I'm not looking at the yellow highlighted. Now I'm looking at the perfect cubes, and I'm looking at the pink highlight. So now the only numbers that you care about are 8, 27, 64, and 125. These are the only numbers that you are allowed to divide by. All right, so I have the cube root of 8. Is that a perfect cube? Yes. Cube root of 8 is 2. A 2 gets to come out from under the radical. All right, so on your a to the 6, now you're taking your exponent and you're dividing it by 3 because I have a cube. So 6 divided by 3 equals 2 that get to come out. And for the b to the 9th, what's 9 divided by 3? Okay, so you have 3 that get to come out. If I were to just focus on this a to the 6 here. So if you have the cube root of a to the 6, 1, 2, 3, 4, 5, 6. There we go. So the cube root of a to the 6, and having 6 a's under the radical sign, these are the exact same thing. When you switch your index, that tells you how many have to go into a group. This says you have to make groups of 3 in order for one single a to come out. So I made 2 groups. That's how I got 2 a's to come out. That's how I got the exact same answer when I divided. So for those of you that are visual people, this is what's happening here. All right, so I have 2, a to the second, b to the third. Good final answer right there. All right, number 13, I have the cube root of negative 64. Would you agree that 64 is a perfect cube? It is what? It is 4. But I have a negative right here. So, if you take negative 4 times negative 4 times negative 4, what do you get? You get negative 64. So if you have a negative number right there and you have an odd index, then the number that you pull out, the root of that, is going to be a negative number. So the cube root of negative 64 is negative 4. So now I have a negative and I have a negative 4. Now I need to work on my variables. So a to the 11th. So you're taking your exponent divided by your index. 11 divided by 3. So it doesn't divide evenly. So how many times does 3 go into 11 evenly? 3 times, with how many left over? Good. So that says that 3 A's get to come out, and now 2 of them are still stuck inside. Now we have b to the 16th. So we're taking 16 divided by 3. All right, so it doesn't divide evenly. How many times does 3 go into 16? With how many left over? So that tells me that 5 get to come out, and 1 is still under the radical. All right, so I have a to the 3rd, b to the 5th, 2 a's are left in, so that reads as a squared, and then just 1b. So if you have 2 left in, I'm saying that that is what its index is right there. I already had a negative. I pulled out a negative number. Negative times a negative equals positive. A cubed, b to the 5th, the cube root of a squared b. Good final answer. If you have an index, you must continue to write it, and it must show up in your final answer. If you have an index of 3 and you end up with no index in your answer, then I'm probably going to dock you about a half a point. And the last one you could work out, I will tell you, it is negative 10 y cubed z cubed, the cube root of 2 x squared z for your good final answer. All right, thank you.